Today I'll show you how to process hemisphere photographs collected from field sites to estimate forest canopy coverage. We use this method during CoreMap CTI project and as a primary parameter for calculating the mangrove health index. Before we begin, we should manage all photographs directory according to each plot, zone, and location. We also need ImageJ software for conducting an image pixel analysis, which could be downloaded freely from the website. Choose the suitable version for your PC's operating system, either Windows or Linux or iOS. Here I will choose the image bundled for 64-bit for Windows and then I will download it. After downloaded, it is no need to be installed, which you only need to extract and open it directly. The ImageJ dashboard is a small rectangle in gray color. Lastly, we open a spreadsheet file, either a new file or using the CoreMap CTI monitoring system spreadsheet template, like this. So that we are ready for analysis since we have managed the photographs. Open the ImageJ and prepare a spreadsheet template file. Let's begin with forest canopy coverage analysis. First, open a photograph file using ImageJ, and this photograph is still in an RGB color combination. Click File and then Open. And find a target hemisphere photograph from our directory. In this tutorial, I will open first photo from plot 1. Secondly, convert the RGB file to be an 8-bit type by clicking the image, type and choosing an 8-bit image type. Thirdly, conduct a threshold adjustment to separate between canopy pixel in black color and sky pixels as white color. An adjustment step is needed due to variable sunlight intensity among pictures in one another plots. We back to click the image in the main menu. But now we choose Adjust Threshold menu and consequently, the threshold window will be open. In this window, you should ensure that all of the canopy pixels are blackened. This step is absolutely crucial since we have to correctly separate the canopy and sky pixels in the appropriate interpretation by scrolling the threshold adjustment. Scroll it into the right or left and right again, and until you meet black and clouds pixels are coming. Click the left scroll to fade the blackout clouds out gradually for precise interpretation. The more we practice, the better interpretation skill we have. Now I will stop at this point. 1, 2, 3 as my interpretation for separating sky and canopy appearance in the displayed photograph. Click Apply to finish the threshold. The next step is to check each pixel number, either canopy or sky, and total pixels by clicking Analyze Histogram, and the histogram window will be displayed. Two fields should be considered in this window, which are Mode and Count. The mode represents the dominant pixel type in the picture, either canopy or sky. In this picture, you can see 255 in the mode. It means that the picture is dominantly composed by canopy components. Meanwhile, if in this value is 0 or null, it means that the dominant pixels are sky in this photograph. On the other hand, the count here represents the total pixel in the photograph. The number of each pixel type can be identified from the list in the histogram window. Find the 255 pixel type below representing the canopy and determine its pixel number in the second column. And then open the spreadsheet. In this spreadsheet, we will input two values. The first one is the total pixels, the second one is the pixels of canopy from each photograph. In the pixel total cell, I will input the count referring the histogram from ImageJ. I will input this value as the canopy pixels here. spreadsheet will calculate the percentage of canopy coverage automatically from this photograph. And now we repeat the previous steps from the next photographs, since the canopy coverage from one plot will be represented by the average of canopy coverage of all quadrants photos. That's all from plot number 1. We are getting 73.1% of canopy coverage percentage. Do the same steps to the next plot to estimate the forest coverage on all sides. Thank you for watching and see you in the next video.